Hey guys, welcome back to another one. So for question 5, I've already decided to solve the question in advance, and here I just want to explain the steps I took to get every single answer, because this is quite a lengthy one. It's better we just look at step by step. Now let's have a read, and we're gonna pretend as if we're solving the question. Yeah. So two trains P and Q move on a horizontal parallel straight tracks. So instantly we have two trains P and Q. For the purpose of this one, the red line here is P and the blue line is Q. Now, initially both are at rest in a station and level with each other. So we assume that the initial speed is 0. Now at time equals 0, P starts off and moves with constant acceleration for 10 seconds up to 25. So this is where this line came from. So it increases at some acceleration for 10 seconds. Ignore the 2.5s for a moment. It increased for 10 seconds, yep, up to speed 25. And then moves at a constant speed of 25. So this red line means it's carrying on. At this point, we don't know how far it goes, but you'll find out as you go. Now, at time 20, so we're here, train Q starts to move in the same direction as P. So actually, what this means is that they both have the same parallel acceleration. So that's why I did these two lines, equal signs, indicating that they're parallel. This will help you solve the T later. So it moves on, keeps on going for the next, until it reaches a speed of 40. And we don't know when that is, so we have to actually find that. And at this point, it just carries on moving at 40 meters per second until it eventually overtakes P at this position here. So we call this capital T. So again, bear in mind the values of 36 and T are not here. And that's it. You just plot this and we're good. Now let's look at part B. So it says find the value of T at the instant when both trains are moving at the same speed. Now the only way to work this is to use more or less parallel lines. I mean, I just calculate the gradient, to be honest, and I realize they have the same gradient. So in a sense, you could use area triangle, or you could just look at it. If these are parallel, then this indicates that this is a parallelogram. So if it moves at a gradient 2.5 and has a distance of 10, this means this also moves at 2.5 and also has a distance of 10. So 20 plus 10 will give us time equals 30. That's it, simple. How I got 36? Well, they don't ask you this, but it's useful for part C. So what I did here is I used a ratio. I said that for a speed of 25, we always get a distance of 10. So if you look at this small mini triangle here, we can see for the next, after an additional 15 speed, and using ratios, you can actually deduce and get 6. Okay, so for 15 units of speed, you get 6 distances. The quickest way is to find 1 unit first, by dividing by 25, so get 10 over 25, then multiply by 15 to get 6. And that's it. Add 6 more to 30, you get 36. Now lastly, let's look at part C. It says find the value of T, the capital T. Now to do this one, we have to take a minute to breathe and think about this. Now you see the two graphs we drew. We can say that the area of the distance P traveled is going to be equal to the area of the distance Q traveled. Why? Because they both overtook each other at this point and they both started at a station. So theoretically, they both traveled the same. Now, in order to calculate this, I use firstly, for P now we're talking about, the trapezium rule. So look at this formula here. To use a trapezium rule, it's going to be the length of one side of the trapezium, the two parallel sides. So this length between T and minus 10, T and 10, so that's T minus 10, plus the whole length from T to 0, so T minus 0, or just T. And you find the average by dividing by 2 and times in by the height, which is 25. And then you repeat for Q. First you find the small length between T and 36 plus T and 20 over 2, and then times it by the vertical height 40. And now all you do is just equate them. Since they have the same distances, equate these two and eventually solve for T. And that's it guys, that's how you calculate number 5.